about what you think the answers are. Ready, set, go. Maybe you agree, maybe you disagree. Maybe you agree and you're wrong, or you disagree and someone's right. Ooh. 30 more. Let me show you what the answers are not. You guys see? Let me show you what the answers are not. Okay, you ready? This is what the answers are not for letter C. That is not a min, and that is not a max of f. Because I'm not looking for f prime's max or mins. I'm looking for f's max or mins. So those are not the relative extrema of f. And these are not the relative extrema of f. They are of f prime, but that's not what the question asked. The question said, here is information about the derivative. You need to take that information about the derivative and apply it to where f is having relative max and mins based on the increasing, decreasing test in the first derivative test. 60 more seconds. The max and mins that you see are of f prime, not of f. Reconsider. Read your first derivative test. It tells you what to look for in or with the derivative. Read your first derivative test. It tells you what to look for or in the derivative. So bad, I just don't get the sound turned off anymore. Mrs. Kendrick, sorry.
Disgusted. That's a logic.
Why am I doing number lines? In order to figure out the behavior of f, which is who I'm looking for, don't I have to look at the sign of f prime? If I had f's graph, I would love to look at him and say, oh, he's going up here, he's going down here, he has a relative min here, he has a relative max there. But who is this not the graph of? It's not f's graph. It's not f's graph. So what was the very first question you guys were supposed to answer? Critical numbers of f are where the derivative, this guy, has zeros or the x values where the derivative equals 0 or pitchfork, where the derivative equals 0 or DNE, where the derivative equals 0 or does not exist. You guys see any places where the derivative doesn't exist? Holes, vertical asymptotes, jumps, anything weird going on with the derivatives? No. So forget the DNEs. The original functions didn't have denominators. And as Ryan was saying, if this is a cube, the original could be a quartic, polynomial denominators. If this is an upside down quartic, his original was a quintic. Fourth degree came from no DNEs, but what are there? Zeros. What are the zeros? -1, 0, and 1. Where are the zeros of the derivative? -1, 0, and 1. If I can move them to be a little bit even. Where are the zeros of that derivative? -3. Oh, there was a reason I was telling you where it was hitting the x-axis? -3, 1, and 5. Those are your critical numbers for letter A. So letter A for the critical numbers, I could put that here, I suppose. My crits for this guy, x equals. Why? Because the critical numbers are when the derivative equals 0. And how do I see that in a derivatives graph? The x-intercepts. Those are the zeros of the derivative, like the card says I need. What am I going to do next? Well, letter B says to figure out where f is increasing or decreasing. There's a forever card for that. How do I know when a function is increasing? It's going up. Great. What if I can't see it? Oh, its derivative has what sign? Positive. And then the function's decreasing when the derivative has what sign? So if these are the derivatives, y equals f prime of x, y equals f prime of x, I will know the signs of the derivative by looking at the signs of the y values. All you have to ask yourself is above or below. On the left of -1, are the y values above or below? Above. So what signs would all these, if I were to go to -2, that point, the y is positive. -3, that point, the y is positive. -4, that point, the y is positive. The derivative is positive, 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 positive. Oh! The y values of the points to the left of -1 are all going to be positive numbers. I'm not looking at increasing, decreasing of the derivative. That's the most common mistake. I'm looking at the signs, above or below. That's the easy way. So the function's above, so the y's are positive. But what happens in between -1 and 0? The function goes below. So all these points have what kinds of y's? Negative ones. And then the function goes, the derivative function goes above. And then the derivative function goes below. Positive y's, negative y's, positive y's, negative y's. I'm not looking at the movement. I'm just looking at, oh, it's up, oh, it's down, oh, it's up, oh, it's down. So how would you guys fill in this sign chart? What sign should be on the left of -3? Has to be negative because it's below. But it's increasing. I don't care. I'm not looking for f primes increasing. I'm looking for f's increasing. So I just care that it's below. So what's the sign in between -3 and 1? Positive. How about in between 1? Positive. How about in between 5 and infinity? Good, because it's below, above, above, below. So now what can I say about the behavior of f? Well, anytime there's a plus, isn't f going up? And anytime there's a minus, isn't f going down? And Ryan, do you see your quartic? Good. On this one, I have decreasing, then increasing, then increasing, then decreasing. What? We're not necessarily being asked to draw the graph of the original right this second. However, if we were, we would probably do something like, oh, that has a, and then that has a, and then that has a, and then that has a, something like that. It would need to be matched up pretty perfectly, though, because wait a minute, how did I know to make mins and maxes? Why are the mins and maxes actually at the zeros? Because what's going on in between, guys? I'm just going to put the sign charts as letter B, even though we would need to actually answer like, oh, hey, increasing from -infinity to -1 and from 0 to 1. But you guys can see the sign chart. You can make conclusions from the sign chart. What I'm asking for is where my relative minimums and where are my relative maximums? Do I have any mins? Yeah, there's one right there, but follow the flow. Where's the min happen? If it's all smooth turned, the derivative never does not exist. 0. Ah, now here's the struggle. You're not allowed to put a y value because I don't know what the original function is. So to be honest, I don't know for sure where this happens besides the fact it's when x equals 0. For instance, this could be like a really, really shifted up, narrow, like, oh, there's a max, and oh, there's a min, and oh, there's a max, and oh, there's a... Like, I don't know where this point is. All I know is at the, or on the, or when x equals 0, the minimum will occur. So no plugging in y values, because I don't know what the y is. I don't know where the point is. I just know it happens at x equals 0. How about maximums? -1 and 1. Because all it takes to have a relative min is for the function to exist, which they tell us, well, actually the derivative exists everywhere, and if a function is differentiable, then it must be continuous. So I know the function's continuous to begin with. So therefore the whole, like, all the points existing, check, that's true. And then the derivative changes from negative to positive at 0, so that's a min. You could also say f changes from decreasing to increasing. You just have to use the right letter with the right clue. F prime goes from negative to positive is good, or f goes from decreasing to increasing. Either one's okay. So what would you guys say over here? Any relative min? Where? At -3. Any relative max? I agree with 5. Why do I disagree with 1? Yeah, it goes up and it levels off and it goes up again. Oh, that's, didn't they ask at every critical number, at each critical number, whether it's a relative max or relative min, or why is 1 a neither? Because there's no change in direction of f. There's no change in sign of f prime. Dun, 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 dun. Questions? So what was the most common mistake? Yeah, being like, oh, look, it's a high point. Oh, look, it's a low point. Oh, hi, it's a high point, low point, high point. Critical numbers, yay, at each of the highs and lows. You were doing good calculus, but only if you had been given the graph of f. And who were you given the graph of? If I were you and you're a highlighting person, go get a highlighter and highlight this problem, because it is oh, so good. So good. Because the AP loves to give you graphs of the derivatives and force you to analyze the original, aka give you f prime and ask you about f. Tricky, tricky, tricky. With that, let's go ahead and, that's with an equation, that's easier. Let's go ahead and transition to homework. Oops, I did not mean to open whatever that is. Okay, as we transition to homework. Oh dear. Yeah. Yeah, go ahead and pop open the door, bud. Go find a doorstop. You just have to kind of jam it in. So my computer's moving slower than molasses. All right, as you guys wait on me, because my computer's taking forever in a day. Yeah, it is colder in the hallway. Hey guys. I know, you're used to having to wait on me because my computer's slow, etc. And you are going to have to wait on me to check your homework, but you have your homework spirals out and your colored pens at the ready. We're going to go ahead and take a couple pages as notes while my computer's trying to catch up. I don't know what's going on today. Just hang in there. Your homework is loading. Keep your homework spiral out, colored pen at the ready. But we may as well see where we're going in section 3.4. Concavity, we were just talking about increasing and decreasing. That's what the first derivative tells us. Concavity, do you guys see the test over here? Who tells us about concavity? The second derivative, yeah, buddy. The second derivative. Ruth, are we writing down notes, kiddo? Oh, you're just figuring out how many pages to skip. Joyce, did you figure that out too? How many pages to skip? Okay. I'm going to freeze the screen, go grab a yellow box, and see how the homework loading is going. Silly computer. It's all right, my power went off this morning. It's just not a good technology day. Hopefully it comes back on before everything in my fridge spoils. So increasing, decreasing. That was what we did in section 3.3 with the first derivative. With the first derivative. Section 3.4, now we need the second derivative. So right now I'm adding to your backboard a homework number 20A. Ooh, 20A. What do you guys think is going to be due before the actual homework 20? Derivatives simplified. For those of you that did the derivative simplified over the weekend, was homework faster last night than it would have been otherwise? Well, meaning if you hadn't done the derivatives ahead of time, just imagine homework last night. You would have had to do the derivatives first, and then it would have been brutal, right? Yeah, yeah, yeah. Just do a quick swoop, and then we'll zoom in on it. Do a quick swoop on the graphs, and we'll zoom in on it. Don't stress about details. Analyze how the slopes of each of the following are changing. Graphically. Graphically. So kiddos, with homework 20 is due Friday, but homework 20's derivatives simplified are due tomorrow. Fewer problems in homework 20. At least fewer derivatives. Why? Because you're not just finding the first derivative, you're finding the second derivative. Oh! You're not just finding the first derivative, you're finding the second derivative. You got to go 2 times and simplify them. So derivative simplified, due tomorrow. I'll go ahead and make a new Google Classroom assignment because once again, you guys don't want to do this for every single homework problem if it's not necessary. So I'll make a Google Classroom assignment. Number 1, you get points for the attempt. And then number 2, I narrow down which ones specifically you need to find derivatives of, so you can ignore the rest of homework until tomorrow night, okay? Patricia, sorry. Not 20A. 20A is literally like get the function, take 2 derivatives of it. Because the other one was take 1 derivative of it, but this one's take 2 derivatives of it. Okay. What are you guys used to seeing when you see concave up and concave down? Are you used to seeing portions of graphs or like whole frowny faces, smiley faces? Smiley faces. Smiley faces, what's that? Concave up or concave down? Yeah, because think, your mood is up, and then frowny faces are concave down because your mood is down, true? Well, it's something silly. That's a silly way of remembering it. So that's what I'm going to fill in the very beginning or the very top for concave up, concave down. That's what you're used to seeing. But it's going to get a little bit more involved here. Because do you guys see the 2 sketches down below? You don't necessarily know everything that's going on in them. But do you see how it's not a full smile and not a full frown? Okay. So with concavity, we'll zoom in just a second once we get back to our notes. But with concavity, even though you are used to concave up like a cup, concave down like a frown, like even though you're used to that, to be concave up, you don't necessarily have to have the full smile. This is concave up, and this is technically concave up and increasing. What would concave up and decreasing look like? No? This is concave up. Do you guys see how it fits as part of the smile, right? It's concave up and increasing. What would concave up and decreasing look like?
Oh, the other side.
Yeah, wouldn't it just be the other branch, right? It'd be that branch. So you could just have this little branch of concave up, or you could just have that branch of concave up, and they're still both concave up. So wait, I don't get it. So concave up, you can increase and you can decrease? Concave down. What's this one, guys? Concave down and increasing or decreasing? Yeah, and increasing. You can also have concave down and decreasing, which would look like this instead, right? So you can have concave down and be decreasing, have concave down and be increasing, have concave up and be increasing, concave up and be decreasing. So guess what? Increasing, decreasing, the function going down, going up, does not determine concavity. So what does? The increasing, decreasing does not determine concavity. So what does? Can I zoom in really quickly before we transition to homework? What is the same between the two concave up branches? Not the increasing, decreasing, because you can have one or have the other or have both. What's the same? Don't look at the function and what's going on with the function going down, going up. Look at the slopes. What are the slopes doing over here? Decreasing? Imagine this was like a -5 and a -3 and a -1 and a -0.1, and isn't that technically going up? They're getting less steep, but the negative numbers are getting closer and closer to 0. On a number line, that's going up. And what's happening over here? The positive numbers are getting higher. So what's technically going on? The slopes are always, what were you saying, Ryan? Increasing. Slopes, aka F prime. No, that's getting less steep. But negative numbers are getting more positive. The numeric values, not the absolute value, but the numeric value. Negative numbers getting closer to positive numbers, that's going up on the number line. So I'm not saying slopes are always getting steeper. That would be like an absolute value type thing. I'm just saying the numeric values of the slope are getting more and more and more and more and more positive, aka always increasing. But what's going on to the slopes down here? The negative numbers are getting more what? More positive. Oh, careful. No. More negative. Remember, the higher the number value, the higher the absolute value, the steeper the slope. So -5, -10, -50, -100. That's going down on a number line. And what's going on over here? Positive numbers are getting bigger. Wait. How does slope work? How does slope work? Trace for me from 0, 0. Like put your finger on a point. Just go. Put your finger on a point. Okay, I want you to go a slope of 1/5. That's a very tiny number, right? Slope of 1/5. How do you do that? Up 1 over. Ooh, that's not a very steep line. If you have a tiny slope like 1/5, that's not a very steep line, right? Now trace a slope of 5. Up 5 over 1. What happens when the number gets bigger? The slope gets steeper. So if I have steep positive, like maybe 5, maybe 10, closer and closer to 0, aka what's happening to the slopes? Getting smaller. Good. So the positive numbers are getting smaller and the negative numbers are going more negative. Whatever you do in a number line, positive numbers getting smaller, negative numbers going more negative. What's true about both of those movements? You're going down. What's true about both of those movements? Negative numbers going up or positive numbers getting higher? You're going up. So slopes are increasing for concave up and slopes are decreasing. For concave down. Now I'm not saying that one graph can't have some concave down and some concave up, but what I'm saying is on a concave down portion, The slopes are always decreasing, aka the f primes are always decreasing, and we'll see how that ties in together with the concavity test in just a second. Wait a minute. Concavity test? I thought we were supposed to be looking at the second derivative. Doesn't increasing just say box is increasing when box prime is positive? It's really just the increasing decreasing test applied. Box is increasing when box prime, f prime's prime is f double prime, is positive. And box is decreasing when box prime, f double prime, is negative. And maybe we'll have to change the wording of that one just a little bit to keep those college professors happy. But for right now, this is going to be forever number 40. No, 40. Whew, no. No, no, no. Forever number 23? Forever number 23.
That's great.
It's better than 40. It's better than 40. Why am I trying to show you this? Because I'm pretty sure we're going to have a few homework questions. So what I'm trying to show you is, pay attention. What I'm trying to show you is why I need you to do derivative simplified tonight. If we need to be testing for concavity in section 3.4, I don't just need the derivative. I need to know if the derivative is increasing or decreasing. That's more than a first derivative sign chart or an increasing, decreasing sign chart. I'm going to have to do a sign chart for f prime, meaning I need to know f double prime. So how do you get to f double prime? Ever, ever, ever. Well, first you find f prime, unless they give you f prime. Okay, but if they give you f, you have to find f prime, and then you have to find f double prime, right? But you don't just want f double prime, you want f double prime simplified. Why? Because you're going to have to find zeros and DNEs of the second derivative also, considering the domain. It's a lot like increasing, decreasing test, just the terminology changes a little bit. We don't call zeros and DNEs of f double prime critical numbers. We call them pips. Pips. Possible inflection points. Possible inflection, a point at which concavity changes. Possible inflection points are going to be the zeros and DNEs of f double prime. If worse comes to worse, I'm going to have you guys go ahead and take a picture of this on the way out the door and have it in your notes ready for tomorrow. And then our homework tonight is just finding first and second derivatives simplified. That will make your life so much better tomorrow night. And you'll get points for the assignment due in Google Classroom tomorrow by 7 a.m., which is just what I tell you, only the problems I tell you to find the second derivative simplified. Does that make sense? Okay. Those of you guys that didn't take my advice seriously, homework last night would have hurt so bad if you didn't do derivative simplified and you got a 0 on a Google Classroom assignment. That sucks. All right, here we go. So, homework 3.3, let's go ahead and grade. I think I just passed the entire homework 3.3. Lo siento, let's go back. Here it is. Oh, that numbering is awful. Okay, ignore the numbering. Let's look at the evens. What did the book choose to do as far as like how they did their sign charts? Chart or number line? Chart all the way. Oh wait, but they wrote it all funny and weird with inequalities. What should you have done instead if you did the chart? Just write the intervals. It's so much easier, so much faster, right? So much easier, so much faster. But I just need to take a vote real quick. How many of you guys did number lines? How many of you guys did charts? Okay. Wow. Wow. How many of you guys, even though you did the chart, would say you understand the idea of the number line? Okay. Just making sure if I use the number line because it's faster than me like making columns and rows, etc. Okay, long story short, number 6, lo siento. Decreasing on, you guys can check out your intervals. Increasing on, you can check out your intervals. I would say check the derivative, but you already should have done that part, right? And for those of you the guys that were gone yesterday, in homework 19A, the derivative simplified, it's in the video if you watched it. But I put the answers to all the derivatives in Google Classroom. Number 8, you guys can check out your increasing, decreasing. They actually write the words. I just had you guys write like the up arrow, down arrow. They actually write the inequalities. I just have you do like positive, negative, negative, positive. So I apologize. It's going to take your brain a second to be able to check, but hopefully we're good. Number 12. Up, down, up. Remember, you're not checking the derivatives. You shouldn't be. You're not checking the critical numbers. You shouldn't be. You should just be able to look at the chart and say, did I figure it out? Here's the increasing. Here's the decreasing. Did you guys have to do a lot of like mental math with plugging in last night? Okay, are we going carefully? Okay, careful. Some of these might just be you plugging in mistakes. It happens every time it happens. It depends where you plug in. Sometimes it's easier, sometimes it's harder. For instance, I would say on this example, number 26, I wouldn't plug in here. That's gross. Oh, I have to figure out what the actual number is minus that actual number. This is easy. Positive times a what? Positive, or positive times a negative, or a negative times a positive. That's easy if it's factored. It's so much easier to figure out the sign and not have to figure out what the actual numbers are and subtract. Blah. Just a strategy, though. Sorry, 26, the answers are right down here at the bottom. Ooh, you started going to relative mins and maxes. But careful. Since they gave you the original function, they weren't just giving you the x, they were giving you the point. The x and the y. They weren't just giving you the x, they were giving you the point. Unlike the warm-up today. You were given f, so you can plug into that to find the y. Not just the x, but the y too, also. Number 40. You guys can skip right down here, right? Increasing, decreasing, relative max, relative min. Increasing, decreasing, relative max, relative min. Don't worry, I'll let this keep showing for a little bit longer. But 42 was the nasty one with a piecewise function, but good thing we kind of did an example like that yesterday. I told you guys to keep an eye out for the piecewise and see if it was discontinuous or not. But when I look at this guy, -2 plus 1 is -1. 1 minus 2 is -1. This one was actually continuous. So you didn't have to worry about any domain problems or discontinuities. Now, his function wasn't differentiable at -1, 2 and 0. 2 and -2 don't match up. It's a sharp point, but can a sharp point still be a relative something? Yeah, which is why down here, even though -1 was a DNE of the derivative, and then we had to put him in our sign chart, he actually did show a relative max, and that's okay, that's legal. He's not a discontinuity, he's not a domain problem, he's a sharp point. He's a DNE of the derivative, but he still exists. He still exists. With that though, let me go back to that one I asked about yesterday. If you guys have your notes, oh, it's going the wrong direction. If you guys have your notes close. Where was that one that we had to kind of, no, it wasn't the motion one, this one. This one. The sign chart says relative max. The derivative did not exist, but that doesn't matter. The derivative doesn't have to exist. I can have a sharp point, but the problem isn't so much that the derivative doesn't exist. This was the problem. The function existed at 0. Plug in 0. There's a point at 0. No big deal. But the discontinuity, my question I left you guys with yesterday, does the discontinuity mean I do say there's a relative max, or I don't say there's a relative max? That's what the final answer is. I don't. Why? Because to have a relative min or a relative max, you need to have a critical number which cannot include discontinuities. Now we still put the 0 in the sign chart. A discontinuity is important. Put the 0 in the sign chart. But technically, even though the derivative does not exist, because it was a discontinuity, we would not classify this guy as a critical number. How is that different from homework? Well, homework, I didn't have to worry about it because it wasn't a discontinuity. -1 equaled -1. It matched up, so it was allowed to be a relative min, which it was. Sorry, a relative max, which it was. What else do we got? 78, they said the slope was 2 because they're geniuses and they know what problem they gave you, but the bigger question, did you guys figure out that the slope is just a horizontal line, it's constant? The slope is constant, hence the horizontal line. Number 80, this is kind of what Ryan was thinking of. F prime is going to be a cubic if the original is a 4th degree. You don't have to say like, oh, I went as high or as low as they did, because to be honest, you probably wouldn't know. But you could be like, oh, it was a cubic. It was some sort of swoop, swoop, swoop. And that has to do with the function was decreasing, so f prime was negative. The function was increasing, going steeper and steeper, and then less steep, less steep. Then the function started decreasing again, and then coming back, decreasing slower, and then increasing. And that kind of denotes our quartic polynomial. So decreasing to that relative min, and increasing to that relative max, decreasing to that relative min, increasing after. Are these the last ones? 88 and 100? Yeah. 88 was a little bit messy because you guys had to use chain rule, but chain rule wasn't too bad because isn't your u prime just 1? Oh, so then you just have to plug in 8 and then you can go ahead and look on the, I think it was a graph for number 88. And then 100 was the motion-y one, kind of similar to what we were doing in homework. Tomorrow, at the beginning of class, we're going to go ahead and go over any even questions that you have, because you just saw them for the first time as far as the solutions right now. I mean, you saw the critical numbers earlier when you were checking your derivatives, hopefully, before going ahead and doing the rest of homework. But that doesn't mean that you don't need a little more time to digest what's going on. For instance, some of you might be like, why on earth is this a closed interval? I don't get it. We've been keeping them open all homework long. We'll go over questions on the evens tomorrow because we don't have like a full homework due. It's just derivatives simplified. But odds, you guys already struggled through. You already tried. You were able to check not only the derivatives, but the whole thing on CalcChat. What odds are we stuck on? First of all, sorry, what page is homework? 2 what? Yeah, Grace. 53. Anything earlier than 53, guys? 19. Okay, let's start with those ones, and I'm not sure I'll get many more done besides that. I'm just looking at the directions for number 19. Oh, just increasing, decreasing. Even if you didn't struggle with 19, guys, why would someone not like number 19? What was different about it? Ah, there's an ln. And it's a product rule, right? So, ooh, and it's an ln of a u? So I would say x squared times ln of, I would have rewritten it to be 1/2 x. I think that makes my life a lot easier. Okay, we know we need the derivative to find critical numbers to do an increasing, decreasing sign chart. So I'm going to do second d first, which ends up being 2x, plus first d second, that's going to be x squared times, what's 1 over 1/2 x? Oh, 1 over x over 2 is 2 over 1 over u for ln, so 1 over x over 2 flips it. Uh-oh, times u prime. Do you guys get the u prime? Why am I going to do one of these? Oh, it's not green. Why am I going to say remember the green trick? Combine like terms, maybe you can pull out stuff, etc. Maybe we should rewrite it a little bit. For instance, those simplify and that simplifies. But then I see that both of them have an x. Can't I pull an x out? So I would get 2 ln of 1/2 x plus 1. Okay, how do I find critical numbers? I set the top equal to 0, bottom equal to 0. Technically, domain, x over 2 has to be greater than 0 because of a logarithm, which means x has to be greater than 0. Maybe some of you guys didn't think about domain. But then down here with critical numbers, we would set each of these guys equal to 0. Not really DNE, because there's not like a denominator. I already figured out his domain problem. There's not really any extra DNE to look out for. My critical numbers, I'm going to end up with x equals 0. That's 1. Oh, is x even allowed to equal 0? Well, forget that. It's not even allowed. That's a DNE from the very beginning, from the get-go. But this guy, can't I subtract 1, divide by 2, e to both sides? You get rid of that ln. That's going to lead me to 1/2 x equals e to the negative 1/2 multiplied by 2, x equals 2 e to the negative 1/2, or if it's easier on your brain, 2 over root e. Negative says denominator, 1/2 says square root. So then what would I have done? You would have needed to start at 0, open, not closed, for your sign chart if you're doing the number line. Or in your intervals, you start at 0, go to your critical number, which is a positive. It is in here somewhere. So your intervals would be 0 to this guy and this guy to positive infinity. Then you can test for your signs of the first derivative. Now some of you might be like, I don't know what that is. Well, pause. 2.71828-ish, square rooted, it's a little bit more than 1. 2 divided by a little bit more than 1. Oh, well, it's lower than 2. But 1 could be in here, so I could do like a test point of 1, and then a test point of 2 over 1 point something. I mean, like 3, 4, 5, 10, all of those are going to be over here. So you could plug in a 1 and plug in a 5. That should be good. And you're plugging into the derivative. You might need to think about ln's graph just a little bit, how ln hits 0 at 1, and ln's negative before that, and ln's positive after. Positive after that. That might help you just a little bit too. But does that give you enough to go on? Okay. And then AJ, you said number 31. This one, you're still doing increasing, decreasing, but you're going on to do relative extrema, right? Okay. 31, it's yucky because there's a cubed root, I think. It's x to the 1/3? That's tiny. So x to the 1/3. F prime of x is equal to 1/3 x to the negative 2/3 plus 0. That goes away. Make it easy on your brain. That's 1 over the cubed root of x squared. That's annoying. Top equal to 0, bottom equal to 0? I think x equals 0 is my only critical number, right? The domain is all real numbers because it's a cubic root. There's no domain problems with that. So that's why I'm going to have my entire number line just with a 0. And then you can plug in before and after. I think this makes all the difference, AJ, as far as plugging in, because a negative number squared is a positive, and a positive number squared is a positive. So this one's kind of boring. There's no relative extrema. It's increasing and increasing. Yeah. And then, Grace, you said number 53? Yeah. What do you guys notice about all the questions that have been asked so far? One had a log, one had a cubed root, and this one has an e. Are you guys stuck on the concepts, or more just you don't like it when it gets messy? Yeah, some functions get messy. They're harder to analyze than others, so that's good for you to see. And another reason to be really careful with your derivatives tonight for section 3.4. When you guys take this derivative, bottom, d top, remember the derivative of e to the u, help me out, e to the u times u prime, common mistake there. And then top d bottom, which is going to be the same thing, e to the 2x times 2. I love seeing the same thing, don't you guys? Because what can you do when you see the same thing? Pull it out. 2e to the 2x, and you're going to end up with e to the 2x plus 1 minus e to the 2x. Well, don't the e to the 2x's cancel? I think you just get a 1 left over. All over e to the 2x plus 1. Double check my derivative, but I think that's right. So then is that right? Oh, thank you. I didn't even show the squared. But the numerator's good, Grace? Okay. So then my critical numbers, you set the top equal to 0 and the bottom equal to 0. Now exponentials are funny, because if you think about just a general exponential, does he ever hit 0? If I divide by 2 and ln both sides, ln of 0 doesn't exist. An exponential can never hit 0. It has a horizontal asymptote at 0. Doesn't cross through. But this guy, well, we could try that. E to the 2x is equal to negative 1. Wait a minute, can I take ln's of negatives either? No. So I have no critical numbers? Yeah, I have no critical numbers. What's my domain? Exponentials domain-wise is fine. So this is one of those awkward ones where literally the sign chart is just a number line with no breaks, and all you have to do is throw in a number and test it. And if you throw in 0, it's a positive, so guess what? This guy is increasing the whole time. What's your job tonight? Derivative simplify. Wait, first or second? Second. So you have to go through the first. But what I want you to do right now, take a picture of the page that says how to deal with the concavity test. Take a picture of the page. Picture of the page. Have it in your notes ready to go. I'm not going to give you extra time at the beginning of class tomorrow. Take a picture quick. It's on the video. It's also saved on Notes Online. If you want to access it there, that's okay too. Or come to class a few minutes early and then just write it down quick before the bell rings. Bye, guys.